All right, nerds, so we're back. Now, we're going to talk today about electrostatic charge. So we've talked about what electricity is, sort of. I'm going to go into a bit more detail about what the charge is and how to acquire it. So basically, by the end of this, you should be able to identify that objects can hold either positive, negative, or neutral charges. Okay? You should be able to determine the overall charge of an object in a diagram, and you should be able to understand that moving charge is usually the movement of electrons. Okay, so when we see this charge moving from here to there, that's a lot of electrons cracking down to the, what looks like the ocean, but zoom, bang, that's electrons. Yeah, that's a lot of electrons. Now, what is a charged object? So we depend on it's basically the ratio of subatomic particles. Remember, protons, electrons, neutrons, who cares, ignore them. But protons and electrons, it's the ratio. Protons are positive. You got more positive particles, so more protons than an electron in something, it's going to be positively charged. Okay? If you've got the same amount, it will be neutral, and that's most things, because that's stable, and they all want to get to that point. If you've got more electrons on something than you do protons, it's going to be negatively charged. And so that's a net positive, net negative. All right. Now, that's how that's affected. And we see that down here. Here's a diagram of a little ball. Now, our little ball has 6 pluses in it, see? It's also got 6 minuses, or negatives. Minuses, negatives, whatever, it doesn't matter. It's got 6 negatives, 6 pluses. So you've got 6 positive charges and 6 negative charges. You put them together, you've got 0. No net charge. This object is neutral. Now if we look at this one, it has 8 positive charges and 6 negative charges. So 6 plus minus 6. This gives you a net charge of plus 2. It is positively charged. Plus 2. Here we've got 6 positive charges, and it's got an extra 3. It's got 9 neutrons, so 9 electrons. So it's got an extra 3 electrons. So it's charged. So 6 plus minus 9 is minus 3. So the net charge is minus 3, and this object is said to be negatively charged. So when you're given a diagram and it's got more positives than negatives, it's positive. It's got more negatives than positives, it's negative. And this is why you always need to be careful when you draw your diagrams, by the way, because they mean something. Like, you know, the amount of, if you draw a bunch of positives and you're not paying attention and you draw less negatives, well then that means it's positive charge. All right, movement of charge. So how does something, well, okay, we'll get into it. Now, basically, when charge moves, so that's current electricity which we have in our circuits in our house, or build up a static electricity that goes from one thing to the other, it's usually the electrons which are moving. The overall charge of an object or of an area, whatever, remains the same. So the law of conservation holds true, and the universe doesn't fail to exist as we understand it, and we zip into nothingness. And that's good, because we don't want that to happen. So the overall charge, because of the law of conservation, remains the same, which means you've only got, like, the charges aren't created or destroyed, they just move from one place to another. For example, this ruler has 9 positives or negatives. 9 positives, 9 negatives. The cotton cloth has 5 positive charges, 5 negative charges. So we see if we add them together, we've got total 14 positive charges, 14 negative charges. So we then rub them together like a maniac, and the ruler still has 9 positive charges, because remember, it's usually the electrons that move, and 12 negative charges. So it's negatively charged, like a minus 3. The cotton has 5 positive charges and 2 negative charges, because see, they moved onto there as it was rubbed together by friction. So the total number of charges is still 14 positives, 14 negatives. They've moved, but they've not been created or destroyed. The total charge is the same. It's conserved. And that's because the law of conservation of energy is super, super important. All right. So that's how we show charges, and that's how charges move.